Good morning, CP Calculus class. This is Miss G. It is Tuesday, March 24th, and I had a couple of questions on yesterday's integration by substitution problems. So I'm going to go through problems 11, 15, and 16 on page 329. Okay, I do have a couple of problems at the end, so if you already know how to do these, you can check out the two problems at the end of this video. All right, so number 11, what we're looking for is a function within a function. And so our inside function in the integral of 7 minus 2x quantity squared times negative 2 dx, the inside function is 7 minus 2x. The derivative of 7 minus 2x is negative 2 dx. So now, what we're doing with this is we're taking this substitution and we're going to rewrite our original integral using the substitution. And again, I picked 7 minus 2x as my u, then I took the derivative of that, and what I notice when I take the derivative of 7 minus 2x, that the derivative, which is negative 2 dx, is the rest of the problem. That's why I have it underlined in blue here and over here. So, the substitution goes like this. Our u represents 7 minus 2x. That comes out, the u goes in. We keep the exponent, the second degree here, squared, and our du covers negative 2 dx. So now this integral says the same thing as the original. So now I'm going to just integrate, and we're going to add 1 to the exponent. We get u cubed. We divide our coefficient, which is 1, by the new exponent. We get 1/3, and then we add a plus c. So we have 1/3 u cubed plus c, and then we take out the u and put the x's back in, which gives us 1/3 times the quantity 7 minus 2x quantity cubed plus c. And that's our answer. That is the integral of this quantity up here. Now, yesterday I didn't go over how to check this, but when we integrate something, we're assuming that this integrand, which is what we call this right after the integral sign, is the derivative of some function, and what we do when we solve this or evaluate it, we get the function whose derivative is 7 minus 2x squared times negative 2. So, to check it, we can take our answer, take the derivative of it, and we hopefully get the integrand back. So if I take my answer, which is 1/3 7 minus 2x to the third power plus c, and take the derivative of it with respect to x, I'm going to use chain rule, which is 3 times 1/3. 3 times 1/3. Keep the base the same. Drop the exponent by 1, so the exponent becomes 2, and take the derivative of the inside function, which the derivative of 7 minus 2x is negative 2. And then plus the derivative of the constant, which will be 0. The 3 and the 1/3 cancel out. We're left with 7 minus 2x quantity squared times negative 2, which is our original integrand. So that checks that our answer here was correct. That's number 11. Okay, on to number 15. Oops, let's see. Here we go. Number 15 is the integral of the square root of 4x squared minus 5 times the quantity 8x dx. So now we look for the inside function, the function which is inside another function, and that would be 4x squared minus 5, because that's under the radical. So now that's our u, 4x squared minus 5. We take the derivative of what we picked for our u, and the derivative of 4x squared minus 5 is 8x dx. Now, we come back to our problem and we use this substitution. So 4x squared minus 5 is replaced by our u. The square root's already still there, and that's the 1/2 power. And the 8x dx is represented by our du. 8x dx, that's our du. So now we've simplified the original problem into a form we know how to integrate. So we add 1 to the exponent, we get 3/2. We divide the coefficient by the new exponent, and if you divide 1 by 3/2, you get 2/3. So we have 2/3 u to the 3/2 plus c. And then we take out the u and put in the x expression, which is 4x squared minus 5. So our answer is 2/3 times the quantity 4x squared minus 5 to the 3/2 plus c. Now we can check that by taking the derivative of our answer. So let's take the derivative of 2/3 4x squared minus 5 to the 3/2 plus c. So to take the derivative, we use chain rule. 3/2 times 2/3. Keep the inside function the same, keep the base the same. Subtract 1 from 3/2, we get 1/2. And then take the derivative of the inside. The derivative of 4x squared minus 5 is 8x, plus the derivative of c, which is 0. Now 3/2 times 2/3 gives us 1. So now what we have is 1 times 4x squared minus 5, that quantity raised to the 1/2 power, times 8x. And then we can write that as the square root of 4x squared minus 5 times 8x. And that is our original integrand. So check, we got this one right. All right, let's do the last requested problem. You can check your problems because you didn't, I don't think, have this answer in the back of the book. All right, so this is the integral of the cube root of 1 minus 2x squared times negative 4x dx. Again, we look for the inside function, which is 1 minus 2x squared. We take the derivative of of our inside function, which we've assigned to u, and the derivative of u is going to be the derivative of 1 minus 2x squared, which is negative 4x dx. Going back to our problem, I rewrote it as 1 minus 2x squared to the 1/3 power times negative 4x dx. The 1 minus 2x squared gets replaced by u. So we're looking at u to the 1/3, and the du represents negative 4x dx, this part. So now we've rewritten this in terms of u, the integral in terms of u, so that it represents the same thing as the original problem using this substitution. We integrate, we add 1 to the exponent, we get 4/3. Our coefficient here is a 1. We divide it by 4/3, we get 3/4. So we have 3/4 u to the 4/3, and of course our plus c. And then we take the u out, put the x's back in. We have 3/4 times the quantity 1 minus 2x squared to the 4/3 plus c. Okay, let's check that one. We'll take the derivative of the answer. And the derivative is, well, we have 3/4 1 minus 2x squared to the 4/3 plus c. Let's take the derivative. We get 4/3 exponent times coefficient 3/4. Keep the base the same, 1 minus 2x squared. Subtract 1 from the exponent. 4/3 minus 3/3 is 1/3. Take the derivative of the inside function. The derivative of 1 minus 2x squared is simply negative 4x, plus the derivative of our constant, which is 0. So the 4/3 times the 3/4, when we multiply, give us 1. And we still have 1 minus 2x squared to the 1/3 times negative 4x, which, if we write it in terms of radical form, we get cube root of 1 minus 2x squared times the quantity negative 4x, which is our original integrand. Check, we got it right. All right, let's see what we have here. So for tonight's assignment, I only have 2 practice problems. So they're the same thing I just went over and what you did last night. I want you to integrate these using the u-du substitution method that we just did. But the other thing I want you to do is try these and then check them. I didn't write that. Try the following and then check your answer as I have done in the previous examples. So we have the integral of 5x squared minus 1 to the 4th power times 10x dx. That's the first one. And the second one is the integral of the square root of 3x to the 4th plus 9 times the quantity 12x cubed dx. So those are the only 2 problems I have for today. Try them, see if you get this, and then we can move on with a new video tomorrow. And please always save all your work because at some point you will get credit for all this. So please save it, or I might ask you to submit it, but I haven't made that decision yet. But do save the work, okay? All right, hope you have a great day. Bye.